Hello my dear friends, welcome to Toppscholars. Today we'll be discussing about nomenclature system of carbon compounds. So now friends, let's talk about the nomenclature system that was used earlier for naming carbon compounds, which is called as the common name system. Now friends, earlier the number of known carbon compounds was very small, right? And so at that time, in order to name these carbon compounds, scientists used to use a variety of methods, right? For example, scientists used to name the carbon compounds based on the sources. For example, acetic acid and formic acid. Also, scientists used to name these carbon compounds based on the number of carbon atoms that were present in that particular compound. Common name system also included naming the carbon compounds based on their properties. For example, citric acid. Also, certain traditional names were used for naming these carbon compounds. And in certain cases, certain useful and indispensable names were also used for naming these carbon compounds, right? But friends, this common name system was not of so much use, right? Because there are so many carbon compounds, right? As and when the time started proceeding, what happened is more number of carbon compounds were being discovered, right? And so, in order to remember these carbon compounds with these common names was quite difficult, right? So here you can see some examples of common name system that were used at that time. So the first compound we have is CH4, and what is the common name used for this compound? It is methane. The next compound we have is C6H6, and the common name that is used for the compound is benzene. The next compound we have is HCHO, and the common name used for this compound is formaldehyde. What about the compound CHCl3? The common name used for this is chloroform. And what about CH3 twice CO? The common name used for this compound is acetone. So friends, over here you can clearly see how scientists used certain names, right, which are called as common names in order to name these carbon compounds, right? But at that time, the number of carbon compounds that were known to us were very less. With time, more number of carbon compounds were discovered, right? And to name all these carbon compounds with common names becomes quite difficult, right? You need to remember so many carbon compounds with these common names, right? So it is very much difficult to remember millions of carbon compounds with these common names, right? So definitely there should be a systematic way of naming these carbon compounds, right? So that it becomes very easy to name the carbon compounds and also to identify the carbon compounds so that there is no confusion between the compounds, right? And then came something known as the IUPAC system. Yes. The full name of IUPAC system is International Union of Pure and Applied Chemistry. This IUPAC system is a system of naming carbon compounds simply by identifying the parent hydrocarbon and the functional group that is present in the carbon compound. So friends, nowadays the system that is used for naming carbon compounds is the IUPAC system. And what is the full form of IUPAC? International Union of Pure and Applied Chemistry, which is a system of naming carbon compounds by identifying the parent hydrocarbon and the functional group that is present in the carbon compound, right? Now friends, if we talk about the IUPAC system, the IUPAC name of any carbon compound consists of these three units, that is the prefix, parent name and the suffix, right? So the IUPAC name of any carbon compound has these three units, prefix, parent and suffix. So the middle part is the parent name, to which we have the prefix and the suffix added, right? So now let's see how do we write down the IUPAC nomenclature of alkanes, right? So let's talk about alkanes basically now. Alkanes are straight chain hydrocarbons, right? So now in naming these alkanes, we need to remember that the prefix that we have to use is the number of carbon atoms. So the prefix will be the number of carbon atoms that are present in the compound, right? For example, if I have one carbon atom, then the prefix will be meth. If I have 2 carbon atoms, then the prefix will be eth. If I have 3 carbon atoms, then the prefix will be prop, right? So my prefix will be the number of carbon atoms that are present in the alkane, right? And what will be the suffix? The suffix will be ane, right? So here we have an example of a compound, right, that is CH4, right? So as I said, the prefix will be the number of carbon atoms that are present. How many carbon atoms are there over here? 1 carbon atom. So the prefix will be meth. Very good. Now tell me, what will be the suffix? Since it is a straight chain hydrocarbon, right, the suffix will be ane, right? So now just join the prefix and the suffix together. What will it become? Methane. Very good. So remember friends, when you name the alkanes, that is the straight chain hydrocarbons, by the IUPAC nomenclature, always remember the prefix should be the number of carbon atoms and the suffix should be ane, right? So over here we saw how we write down the name of this compound CH4, that is methane, right? Let's take another example, C2H6. How many carbon atoms can you see over here? 2 carbon atoms. Very good. So what will be the prefix? Yes, it will be eth since it has 2 carbon atoms. And what will be the suffix? Ane. Very good. So now just join the prefix and the suffix. What do you get? Ethane. Very good. Here you can see we have a table, right, where we have the name, molecular formula and the structural formula. So the first compound we are going to discuss is about methane, right? What is the molecular formula of methane? CH4. And here you can see the structural formula of methane, wherein 1 carbon atom is covalently bonded to 4 hydrogen atoms, right? So here we have methane, which has the molecular formula CH4, and here you can see its structural formula. The next compound we have is ethane. The molecular formula of ethane is C2H6. How many carbon atoms? 2 carbon atoms. So these 2 carbon atoms are bonded to each other by a single covalent bond, and the 6 hydrogen atoms are attached to the carbon atoms, as you can see over here, satisfying the tetravalency of the carbon atom, right? So each carbon atom is bonded to 3 hydrogen atoms, right? So in this way what happens is the tetravalency of the carbon atom is satisfied, right? So this is the structure of ethane. The next compound we have is propane. What is the molecular formula of propane? C3H8. How many carbon atoms? 3 carbon atoms. These 3 carbon atoms are bonded to each other by covalent bond, right? That is single covalent bond. And you can see the 8 hydrogen atoms, right, they are satisfying the tetravalency of the 3 carbon atoms. The first carbon atom is attached to 3 hydrogen atoms, the second carbon atom is attached to 2 hydrogen atoms, and the third carbon atom is attached to 3 hydrogen atoms, right? So this is the structure of propane, right? To learn more about this topic, download Toppscholars app.